Hey all, this is the beginning of Unit 4. We're going to talk about congruent triangles, but to start we're going to talk about some of the basic things that we need to understand about triangles in order to move forward. There's three concepts here. I put them together because they all kind of go together. They're the basics. First thing we need to talk about is classifying, and we can categorize or classify triangles in two different ways. We can do it by their sides, and the sides of a triangle are just the three segments that form the triangle. So each side is a segment, and they have endpoints that are the three vertices of the triangle. We can also classify them by their angles. Their angles are formed by the sides coming together. So there's an angle there, an angle there, and an angle there. And remember, a triangle is the polygon that has the smallest number of sides and the smallest number of angles, 3. So if we want to classify by side length, we can call the triangle scalene, and that is if it has 3 different side lengths. So the sides are all 3 different measures. Isosceles, that means that 2 sides are the same. And equilateral means all the sides are the same. You could also classify by how their angles are measured. Here's one we are familiar with. If a triangle has one 90-degree angle, then it's a right triangle. If it has all 3 acute angles, remember acute angles are less than 90 but bigger than 0, then it's an acute triangle. An obtuse triangle has one obtuse angle, so that is an angle that is greater than 90 but smaller than 180. An equiangular triangle is kind of the same thing as an equilateral triangle. All 3 angles are the same. So in an equiangular triangle, all 3 angles are the same. We can call that equilateral as well because all 3 sides will be the same. So take a minute here, pause the video, and classify each of these triangles by both the sides and the angles. So for the first one, if you've done that, you can see that all 3 sides are different. So it should be a scalene triangle. And we have one 90-degree angle here. So it is a right triangle as well. So it's got 2 different names. It's a right triangle and it's also scalene. This one here has 2 sides that are the same, so it's isosceles. And it also has a right angle again. So it's a right triangle. So it's a right triangle with one 90-degree angle, and it's an isosceles triangle with 2 sides that are the same length. We have a theorem, the interior angle sum theorem. This is something that we kind of already been working with, kind of are familiar with. If we take all the interior angles of a triangle, they should add up to 180. And you might have known that from the polygons section of Unit 1, where we use this formula 180 times n minus 2. Triangle has 3 sides, so we would do 3 minus 2 here, and it would become 180 times 1, which of course gives us 180. So triangles, interior angles always add up to 180. And that's going to be helpful to us going forward in the next few units when we talk about triangles. So pause the video here for a minute and find the measure of each of the missing angles in each triangle if you know the interior angle sum theorem. So we're looking for x here. So I know that these 3 angles, 30, 20, and x, should add up to 180. So 20 plus 30 plus x equals 180, and we do a little solving, and we get that that missing angle is 130 degrees. So we can also call this an obtuse triangle. It has one obtuse angle, which is 130 degrees. This triangle over here, I can do the same thing. 25 plus 60 plus x should equal 180. Do some solving, and I get that x is 95. X looks like it's 90, but it's not. It's 95. That's another obtuse angle. this is another obtuse triangle. Now we can't really name it by its sides because we don't know how long they are, but we do know a name by their angles, and they're both obtuse. We have another theorem that involves the exterior angles of a triangle. We've talked about exterior angles of polygons, and we know that they all add up to 360, so a triangle has 3 exterior angles that add up to 360. But now we have this new piece of information here that says that any exterior angle is equal to the sum of the 2 remote interior angles. Now this remote interior angles thing is new, I believe. I'll show you what I mean about that. If I have any exterior angle, like this one right here, the measure of this angle is going to be equal to the measure of this angle in here and this angle here added together. So if I add these two together, it will be equal to this exterior angle. These are the remote interior angles because they are the angles that are not supplementary to the exterior angle. So this exterior angle and this one interior angle form a linear pair. The other two interior angles are the remote ones there, the ones that are far away from the exterior angle. So I want you to pause here, use that exterior angle sum theorem to find the measure of the missing angle. And there's 2 ways you can do this. You can possibly use the interior angle sum theorem, but you can also use the idea of remote interior angles. So I want you to try it 2 ways. If you only can do one, and I'll show you both. So here I have 2 interior angles. They're remote interior. There's an exterior angle is what I'm looking for. So I should be able to, now I'm doing this 2 ways. I can add 28 and 58. Those are the 2 remote interior angles, and that should equal the exterior angle. So 28 plus 58 is 86. So kind of just one step there. I can also find the missing interior angle, and then that's a linear pair with the one I'm looking for. So I can do 28 plus 58 plus x like I did on the interior angle problems. Find out that this angle that I've pointed to in purple is 94 degrees. And then 94 plus the one we're looking for should equal 180. Either way, you get 86 degrees for that angle. So I think knowing that the remote interior angles are equal when they're added to the exterior angle, I think that is just a quicker way. Sometimes you have to use this method. Sometimes you can get away with this method for number 2 if for some reason you forget that theorem. But you should know both. Let's see if I can delete this. So same thing here. I have an exterior angle. I have 2 remote interior angles. If I add them together, then I should be able to find question mark. So it's as simple as adding in 35 plus 95 and getting that this exterior angle is 130. Again, I can find the missing interior angle pointed to in purple. Those 2, or that one is supplementary to question mark. So I can kind of do 2 steps if I need to. I can find out that that third interior angle is 50. And then doing a little bit more algebra, I can find out that the exterior angle is 130, which is what I found just by adding the 2 remote interiors. Both methods are completely correct, but sometimes you'll be forced to use the first method, so it's important to know that relationship. So as promised, 3 concepts. They all kind of are simple, I hope. Maybe kind of review. It's a lot of review from polygons, and I think some of these things about triangles you might have already known. So go ahead and try these two problems, these two U-tries. Notice for number 2, you should be trying it 2 ways, just so you know both ways to find question mark. This one's a little bit different here. I gave you the exterior. You need to find the interior. So go ahead and try those 2, and we will discuss them in class.